What is an offset in Kafka? Let's break it down, step by step, so that you not only remember it for interviews, but truly understand its role in Kafka's architecture. Let's start with a simple analogy. Imagine you're at a library and you're reading a very large book, like 1,000 pages. You don't read the whole book in one go, right? You use a bookmark to keep track of where you left off. That bookmark, that's exactly what an offset is in Kafka. What exactly is an offset? In Apache Kafka, an offset is a unique, sequential ID assigned to every message within a partition of a topic. It's like a line number in a long list of messages. It allows Kafka to track and retrieve messages precisely. It's how consumers know where to resume reading, even after a failure or restart. So when a producer sends a message to a Kafka topic, that message goes into one of the topic's partitions, and Kafka assigns it an offset like 0, 1, 2, and so on. Why are offsets important? Kafka itself doesn't force you to consume every message in order. You can choose any offset to start reading from. Committing offsets. Here's a key piece. Consumers commit offsets, usually after successfully processing a message. This commit is stored in Kafka itself, in an internal topic called consumer offsets, or externally like in Zookeeper or a DB. There are two types. Automatic commit happens periodically, risky if consumer crashes before processing. Manual commit, safer, done after processing is complete. In interviews, you may be asked, what happens if a consumer crashes before committing the offset? Answer: the message may be reconsumed after restart, leading to potential duplicate processing unless your app is idempotent. Real-world scenario. Imagine a payment processing system, Kafka topic, payment events, message, user ID 123, amount 100, status, success. Consumer reads the message, updates a DB, and commits the offset. If the offset is committed before writing to the DB and the app crashes, you lose the update. If the offset is committed after processing and the app crashes midway, it will reread and possibly reprocess the same payment event. That's why offset management strategy is critical. Interview-worthy details. Offsets are maintained per partition. Consumers can reset offsets using the Kafka Consumer API, seek, and assign methods. Kafka does not delete messages after consumption. They're retained based on retention policies, not offset tracking. You can configure consumers to start from earliest, from beginning, latest, from current messages, or a specific offset, custom logic, summary. Here's what to remember about Kafka. Offsets. Offsets uniquely identify messages within partitions. They allow replay, resume, and parallel consumption. Consumers commit offsets to track what's been processed. Improper offset management can cause data loss or duplication. In other words, offsets are what make Kafka not just scalable, but reliable and reprocessable. Pro tip: in a system design interview, if you're describing a Kafka consumer service, always mention how you'll manage offsets. It shows real-world understanding. Offsets are the core of Kafka's durability and replayability. They help in tracking consumption. Each consumer can store its own offset and pick up exactly where it left off. Replay capability consumers can choose to rewind to an older offset and reprocess messages, perfect for debugging or rerunning analytics. Parallelism and scalability. Since each partition has its own sequence of offsets, consumers can process data in parallel, improving throughput. Fault tolerance. Even if a consumer crashes, Kafka doesn't lose the data. The consumer can restart, pick the last committed offset, and continue. How do offsets work? Let's say we have a topic named orders with two partitions. Partition 0, offsets 0, 1, 2, 3. Partition 1, offsets 0, 1, 2, 3. A consumer group subscribing to this topic will get messages from these partitions. Now, each consumer in the group tracks the latest offset it has processed in each partition.